This video starts off the lessons for Chapter 5, which covers factoring and algebraic fractions. This video and subsequent ones will discuss the following objectives that you see here. Finding the greatest common factor, identifying and factoring the difference of two squares, factoring a square of a binomial, factoring trinomials, methods of grouping, and then adding, subtracting, multiplying, and dividing algebraic fractions. So let's get started with section 5.1, which is special products. And this is just a review of the things that we talked about in chapter 1 when we come to multiplication. Just kind of a review of the law of exponents. An exponent means that you have that whatever that number or variable is, that base, you have it that many times and you're multiplying them together. If we have a number to an exponent times the same number to another exponent, so we have the same base in both of these cases, then all we need to do is add the exponents. If we are dividing, then we subtract the exponents. A lot of times it's easier if we want to keep positive exponents to say that if the numerator has the higher exponent, then we end up with the numerator exponent minus the denominator exponent. And if the denominator has the highest exponent, then we subtract them as well. We do the denominator minus the numerator exponent, but we keep it in the denominator because it ends up being a negative exponent. If we've got a base to a power and then to another power, then we can just think about that as being that base that many times again. So we can multiply the exponents. We can distribute an exponent over multiplication and division, but not addition and subtraction. So we can only distribute an exponent over multiplication because that's what an exponent means. It means to multiply. And since multiplication and division are inverse functions, then we can distribute an exponent over either one of those functions, but not addition and subtraction. Because addition and subtraction do not mean multiplication, we can't distribute that exponent. The last two here, we know that anything to the 0 power is 1. You can think of it this way. If you have a to the n divided by a to the n, well, anything divided by itself is 1. And if you use that law from number 3, you subtract the exponents, you get a to the n minus n, which is a to the 0. So that is why anything to the 0 power is 1. Likewise, we already kind of talked about this with number 3 as well. If you have a base to a negative exponent and we want to write it with a positive exponent, then we would put it under the fraction bar with a positive exponent. So one thing to keep in mind is that a negative exponent is not going to change the sign on your actual number. It is only going to move it to the opposite side of the fraction bar. If it's in the top, then you move it to the bottom. If it's in the bottom, you move it to the top. But you do not change the sign of the number itself.